Hello and welcome to another episode of Momento Malum today. Domesticated plants often have the potential to spontaneously hybridize with the wild ancestor populations growing in close proximity with them. Such hybridization may lead to gene flow, the incorporation of genes from one gene pool into another. If new genes from one population are continuously incorporated into another population, it may lead to significant evolutionary changes in the recipient populations. Gene flow between crops and their wild relatives and weedy relatives will have important practical and economic consequences as it promotes the evolution of more aggressive weeds. Hybridization with domesticated species has also been implicated with the extinction of certain wild crop relatives through assimilation of the wild population into the domesticated population. This process also tends to genetically homogenize wild populations, making them susceptible to extinction, as well as deplete the gene pool overall. Over the last decade, much attention has been focused on crop-to-weed hybridization as a potential avenue for the escape of GMO traits into natural populations, as well as ways to prevent this from happening. However, the primary aim of this paper by Dr. Bartsch, which I'm citing for this video, is to determine the gene flow between domesticated beet and its wild ancestor, the sea beet. The domesticated beet includes the table beet, the sugar beet, and Swiss chard. This paper analyzes 69 cultivars and wild lines, using allozyme analysis. And here are the results. The genus Beta, of which a beet belongs to, is endemic to the Old World. Cultivated beets have been known for about 2,000 years and were grown in the eastern Mediterranean region. In Europe, the sea beet is largely a coastal species with a wide distribution, ranging from the Canary Islands to the North and Baltic Seas and much of Asia. There is no crossing barrier between wild and cultivated beets. One of Europe's key sugar beet seed production districts is in northeastern Italy. For over a century, domesticated beet seed production has been in progress in this region, with greater intensification since the 50s. All beet populations are usually wind-pollinated, but insect pollination is also possible. In northeastern Italy, commercial sugar beet seeds are produced on 4,500 hectares, with each hectare containing approximately 50,000 flowering plants. At the same point, wild sea beet populations occur on a nearby coastal plain, with some of the populations existing within 1,000 meters of the cultivated fields. If you want to donate to my channel, the links are below. If you want to buy my book, you can also find that link in the description box below. The results found that there is substantial genetic evidence of gene flow between domesticated beet seed production fields into the nearby wild sea beet populations in northeastern Italy. Two genes exclusive to the cultivars but not found in the wild beet populations were found in this wild population. Contrary to the predictions that the gene flow would decrease the size of the gene pool of the wild population, it is found that a crossbreeding would increase the wild population's gene pool, and the populations that had cultivated genes mixed in was on average 30 times bigger than the normal wild populations. There are two possible reasons for this phenomenon. It is possible that the northeastern Italy populations represent a center of diversity for sea beet, and the mingling between populations did nothing. It is, however, unusual for a small population of a wild species range to hold the majority of the gene pool. The second and more likely reason is that the gene flow is the origin of the increased gene pool. There have been studies that showed that Domesticated beets have equal or greater levels of genetic diversity in comparison to the wild beet, and that unlike most other species, domestication actually increased the size of the gene pool in beets. The other conclusion found from the research paper I mentioned was that there is exchange between wild domesticated populations and it's reciprocal, with wild genes continuously being incorporated into the domesticated population. And that will covers everything. Thank you for watching.